reference. So it is class time, and I can probably, you might be able to see my screen, but the in-classers can't see my screen. We are so near the end of everything. How's my onliners doing? Hey, what's up, Carrie?
What happened here?
What happened here?
Yeah. What's going on over here?
Oh.
Okay, so let's see what we got here.
Yeah, they're here to fix it. I'm in trouble, everybody. Brian's gonna get fired again. Again. Oh no, it's a weekly occurrence. It's just an everyday thing. Again.
We're up on the back.
This is Carrie. Carrie's great. She's a great guy.
I just wonder why we're up on the back and we're not up here. It's almost.
I didn't do it, did I, guys? I walked in and it was like this, right? So that sounds like I did it now. That totally sounds like I did it. It sounds like I walked in, it was like this, I swear.
It's up there, so most of the system's working. Through to this monitor.
It seems like it's just a source button on the TV, right? Yeah, that's what it. Yeah, that's. Well, so it went to another one. It says a different thing down there. Switch to HDMI. Yeah. And then and it is on that back screen. So we'll give this a moment or two more. Here, I'll start screen sharing the main screen. So yeah, do whatever you want. I'll be good. So you guys will see the main screen in a second here. Thank you guys very much. If it doesn't work, ladies and gentlemen, in the class, you might have to view it from the back screen. So frankly, you could turn your chairs around, and we'll forego that for a moment. But if need be, you might have to turn your chairs around and watch via that way. It's like we're living in the Stone Age here, right? Because small little screen on the back, projecting to people on the internet. Look at this. They're going to get me fired now. Thank you, Stuart. Stuart's the villain of the class. Oh. Right. Doesn't have it. Hey! They can't see it, but it's working again now. Hey, it's a picture. Bada bing, bada boom. Thank you so much, Carrie. Thank you very much.
Data over here. So much data.
We don't give you any respect. No respect.
Data. All right, man.
Thank you guys very much.
All right.
Thank you, sir.
If you need us again.
Will do. Thank you so much. Okay, so we got everything fixed up. So fun times. Fun times in Stat 201. That's what we say. So I guess I won't leave the class. I'm just gonna play with my hair. It's a normal day. Let me start screen sharing this screen right here. There we go. Let me start putting this one in video. Well, the good news is we finally have the lecture from last time online. Literally, I'll show you what I did. I was so freaked out by it. I was so freaked out to upload it. And I really can't upload lectures to Canvas. It won't let me because they're too big. So let's go here. Has it been taken down already? Well, you see, I'm not gonna be able to view it because unless I log in as myself, we'll forego that. Let's go here to online.utk. Let's log in. So last week's lecture is up. I don't feel so bad because it's a lecture over business analytics, which is very, very important. You guys, last week's lecture was fun, right? Pretty fun times, did some videos. But then we watched Stephen Colbert, and that was a bad idea. Shouldn't do that. Viacom doesn't like that. I shouldn't even mention them now. See, I should be careful watching this lecture even, because there's still a picture of him near the end. 38 minutes in, I think.
Things we started buying certain things, and it's
picture Brian now.
Like that's all the information. That's all X's, which leads to Y predictions. And
just wait for it.
It is kind of crazy what they're doing, and they all of a sudden are like, people are onto us. We don't want people to know that we know they know, or that. Yeah,
has it already happened?
Craziness.
Oh, sorry guys. It's right around here. It doesn't matter. I have
You
a.
can
Let me remove the audio.
do things like that.
I have a screen where I literally say video removed. Like, there it is. I literally got hit with a copyright strike on YouTube. So that's why all the craziness went down. So yeah, that's what, yeah. So I dealt with that problem, and you know what's funny, Gabby? I uploaded it like Friday, like early Friday. I was actually doing office hours on Friday, like at 11 a.m. I was like, I'm going to upload this, I'll get it up quick for you guys. I hope that doesn't come up in the reviews. I feel like that's my one shortcoming this semester is I haven't had them up like right away. I know I need to get better on that. It's just a hard process with the transferring. And then this video had to be edited. And then I was really worried that there'd be something else in here that would get me binged again for, but so video removed for copyright reasons. Check out Surrender to a Buyer Power on Comedy Central. So yeah, they definitely got me. I could show you the email, but yeah, it's just like copyright claim from Viacom. It was done within seconds of uploading. Like, I uploaded it, and then I saw like an email from YouTube, and I was like, oh, my video is taken down. I think they just have scrapers going at all times or something that they can find that. So they Stuart Chicken say he knows what I'm talking about. Yeah, they found it quick. Yeah. For educational purposes. I'm not just re-uploading someone's video. I don't think anyone's going to be like, let's watch Surrender to a Buyer Power when you can watch it on Comedy Central. You're going to look through this guy's hour and 30-minute presentation to find it, or hour and 10-minute with the part in there. Okay, so that's what happened. Sorry for the things last week with that. And there was definitely a huge delay on this one, longer than we normally like to have. But that explains why sometimes I get these problems. But it's online. It's online. There's also been commented to me that apparently the thing I sent out does not have. Let's check this out. Exam 3 documents. So you're saying this is not the.
Yes.
So that's the key. That's the topics. Okay. So you do have a copy of it with the key, but you want the blank. We will get the blank sent to you. So I misallocated. Man, you guys have done the review, right? And also, go ahead and do the review. There's no bonus, but I love you. I will love you forever. It's my undying love for you as a great student in Stats 101 for doing the review. The SAIS reviews. Yeah, you've done those? Thank you, Gabby. Gabrielle and Aslan, can you turn your, I need my volume up. I don't know why I can't hear things. I should be able to hear people's volumes. Let me mute people. Whoa, can I not mute anymore? Let's start. I want to remove. What happened to my options? Why do I not have mute anymore? Am I not the host? Huh? Yeah, should be logged on here too. 2 seconds, everybody. I should be able to hear the noise too. Start here in half a second. So I can't. You see, it doesn't. This is not the host one, but make host, make co-host, allow record, remove, rename, put on hold. Why can't I not mute? Did they fix it, Catherine? Is everything fixed up? Answer a question in 2 seconds. Is the sound quality good, everyone? I'm not hearing noises on my end anymore. Is sound quality good? All good here? Okay, good. Thank you everyone for helping out. Can I not? Wait, unmute audio. What the heck? I can unmute somebody, but I can't mute somebody. I don't know if they changed this recently, but I'm glad sound quality, awesome. I really want to use that mic, but I don't want to transport it. Like if I could just put it in this classroom and have it like welded to this table. Because it's such a nice mic. I mean, it's beautiful. Aslan asked, is exam 3 on Monday, May 8th at 7:15 p.m.? I'm 99% sure that is accurate. That does seem, it's the Monday, and is that the 8th? Cinco de Mayo is the 5th, and it is at 7:15. That does sound 100% accurate. It is in the syllabus. I'll be sending out the room number for all that. And so the big thing is the only way to get the exam moved, is if you have 2 departmental finals in the morning, because then we're required by the university to remove the last non-departmental final exam. So that's literally, if you pull up, so this is a good lesson for everybody, especially UTK final exam policy. Also, you're supposed to tell your instructor 2 weeks before, but I think they should be forgiving on that. But if you look at the policy right here, students are not required to take more than 2 exams on a certain day. The instructor of the last non-departmental final. So if you have 3 exams and the middle one, so you have 3 exams, can't do 3 fingers, and the middle one right here, this pointer finger, it's not a middle finger, it's a pointer finger. So let's do it this way. 3 exams, can't do anything right. And this exam, the middle one, is non-departmental. Then that exam right here would be the one that is moved. If our exam, the 3rd one, was the non-departmental, then it'd be moved. But the last non-departmental final. So like I said, the only way for ours to be moved, sorry everyone. The only way for ours to be moved is if ours is the last ours is the last exam and they're all departmental. Does that make sense? Because then the last exam gets moved. It defaults to just what's the last exam. So that's got everything going on. The final is our exam 3. That's it. I think we're in alumni again, and you guys are gonna hate me. I think we're in the hot room. I'll send out info about this. It's just I send it out when it's a little bit closer, because I mean, you'll get an email. I mean, we're still 2 weeks from today. 2 weeks from today. I'm so sorry. When I saw we were in the hot room, I was like, no! Can't we just go to the auditorium? Maybe I'll say that. Maybe I'll be like, can we just go to the auditorium? Is there enough room? I don't know. I mean, they'll tell me no if they want. If they say no, I'll be like, because we don't want to overcrowd things, But hey, I'm down at TA. I kind of need to be with everyone else. We'll play nice. So that's what we'll do. We'll sit on the floor. We'll do whatever's needed. We'll sit on the stage. We'll be the show. So, I'm always sticking up for you guys. They'll just tell me no. I'll tell them, hey, is it possible? And they'll say no, Brian. I'll say, okay. But I'll still ask. That's the least I can do. Like, why can't you do more, Brian? Okay, I'll try. Hey, how about we learn some statistics? We'll play. You guys want to learn some stats, or you guys want to end class? What's the plan? Learn stats or end class? If we end class, you have to go learn the stats on your own. It's not a good deal, right? Just go learn. I'm done teaching. So I hope.
Are we having like a review on?
Yes. Well, we will review next class, and I don't know my password anymore. There we go. We will review next class, and we'll mainly go over, I think, the practice test. We could switch it up because there is a video posted on YouTube of me reviewing the practice test already. Learn stats. Yes, onliners. Christine and Catherine, extra credit right there. 5 points for both of you. So there is a video of me going over the practice test, but on top of that, we will do it in class 2. We'll do that next class. We used to do reviews in person, but I started making the YouTube videos for them because, one, we actually got a great response. Like, people actually really like that you can go over the video like over and over again and slow it down. So I'm glad they're liking it too in class. Like, oh, you can actually like rewind it and like, what did he say? Let me see it. And I show you everything. Like, I try to make it as explaining as possible. It works out a lot better than us doing it in person because with in person, we've had problems with the right room sizes. We had people show up and they're like, I showed up 2 minutes before and there was no seats. And we're like, yeah, the reviews are pretty popular. They get pretty crowded. Have I not learned my lesson? They do not download. Last one to download, and I haven't learned my lesson yet. So online has voted to learn, so we shall learn. Man, I was going to go home, going to go make some dinner. This is my 5-year anniversary with my girlfriend. 5 years. 5 years. That's longer than high school. Thank you, Gabby. Thank you, guys. So online says all. So 5 years. So good times. There's a meme. It's like it's from the movie, and I can't remember what movie it's from. But they ask a girl like, what's your ideal date? And she says April 25th. It's not too hot. It's not too cold. You can wear a nice jacket. What's your ideal date? What is it from? What is it from, Michelle? Miss Congeniality. Like, what's your ideal date? April 25th. It's such a good joke. That's what it is. Yeah, that's good. That's well-written humor right there. Like, what's your ideal date? April 25th. It's not too hot. It's not too cold. Anyways, good stuff. And so we lucked out. That's why we picked this date. It's the first day we met, though, 5 years ago. Don't time travel and wreck it. You guys got the secret to my existence now. It changed my future. How about we talk about some means here, some quantitative data. Dates are actually quantitative because you can do how many days since a certain day. So we often do think of data as quantitative, but we're going to switch it up and do categorical. This lecture, which we're starting right now, is kind of a switch to things we've already done. Because guess what we're going to do? We are going to have, I'm going to go way it up. I didn't have to go far. What do you see? It's a mosaic plot. And we used to talk about time travel and the Titanic. Nice job, Sequoia, extra credit, and Mariah, extra credit. So there we go. Sequoia and Mariah, new ones right there, extra credit, like it. And we see a mosaic plot. We know what counts are. We know what count data is. We talked about a contingency table and a mosaic plot are best friends. Now, when you get this, and this is big things to know right here, big key focal points lecture, is that you have a contingency table and a mosaic plot, where a mosaic plot shows you the graphical representation and a contingency plot shows you the numbers inside the graphical representation. The smallest block on the Titanic was the what? The people in what class who what? It's easy to see with the contingency table. The second class who lived. It's hard to see, right? But the biggest block is very easy to see. The biggest plot is the crew who died. You see all the numbers? Nice job. Online answering, great answers. I love it online. And so what we're going to try to do in this chapter, and I don't think I went any further, good. In this chapter, we're actually going to have a statistical test because you kind of eyeball these things. You kind of already know. But this test of independence, oh, you guys are going to love this. You guys are like writing out those nulls and alternatives? Writing with statistical notation? Oh, like it. Hey, 5 points. I like that answer. So, but we're going to make it a lot easier here. A lot easier. But this is going to get slightly confusing. Remember what I say. This is for this chapter only. How about we don't use any statistical notation and we just use our words? Does that sound even better? This chapter only, we're going to use our words and not use statistical notation. I just broke Christina and Catherine too. So this chapter only, our words will be used and we will not use statistical notation. So let's look at the Titanic data. If you time travel and went on to the Titanic, what class would you pick? First, second, third, or crew? Frankly, you'd want to be a baby in first class. That's what you technically want to be if you really get technical. But just going off of this data right here, if you time traveled and went on to the Titanic, would you want to be in first or crew? As long as you wanted to live, you would be in first. You'd want to be in first class because we can see it. We understand this. You can see the proportion, that the proportion of people who were in first class who lived was greater than the proportion of people in the who died who were in first class. The proportion of people who died in first class, the proportion of people who were in first class and lived, all this stuff, very associated because we can see the differences between the levels. And that's the way we used to analyze it. If it was flat across, then it wouldn't matter because then it would be the same proportion of everything that lived and died because it'd be like, oh yeah, you live, you die. It doesn't matter what class you're in. But we can see there is a strong association between what class you were in and if you survived on the Titanic. So definitely. What did I say? How do you like this null and alternative? It's even easier than you think. Do you want me to tell you Brian's surefire way of doing the null and alternative? Here it is. You ready? This is for only chapter 22. 2, 2. 2, 2. Survival is independent of class. What did I do? X is independent of Y. Do you see it? Survival is independent of class. Guess what the alternative is? Survival is not independent of class. Done. Null and alternative written, done. All you need to do for these ones is look at the mosaic plot. Anyone watching this lecture now, anyone watching this lecture, when you see the mosaic plot, you know you're in chapter 22. When you get to the test problems, I'll go find, literally, I'm doing this right now. I want to show you how easy this is. YouTube, Stat 201, UTK. I can't stress this enough. I want you guys to do well on the test. I want to see such great grades. I want them to say, Brian, your grades are too high. So they come to me and say, Brian, you're fired again. Again and again. Let's go down to, do you guys see the chi-squared? Let's mute the sound. I think I do it right here. I think I circle them. Right there. Look at that. Age group. Tell me the null and tell me the alternative. Tell me the null and tell me, write it online. Write the null. The null would be that what? Look what I'm doing right there. Age group is independent political party. What's the alternative? And you can put the non-dependent in the middle. I like to do it in the middle, like it's like the equal sign, you know? Like age group is independent of political party. I probably, who knows how I said it here. I like to put it in the middle. And then the alternative is simply just not independent. That's all it is. Is that easy enough? X is independent of Y. Nice job online. First person, Mariah, another extra credit. Aslan, I haven't given you one today, 5 points. Another 5 points back there. Love the answers. Do we understand how to write the null and alternative here? Now think about when you say when two things are independent. Is that a good assumption to make about most things? Like eating cheeseburgers and the letter grade you get on a test. Like if you eat cheeseburgers the night before the test, that'll be independent of your letter grade. Like the meal you eat the night before a test is independent of the grade you get on a test. How about the color of your shoes on the day of a test is independent of your grade on the test? Now I'm talking about letter grade specifically, because what kind of data are we dealing with here? Because letter grade is what? Categorical. If I said numeric grade, it'd be quantitative. These are all counts. Like 5 people with blue shoes got an A. That's a count, right? Because you'd be like, you have blue shoes and you got an A. You'd have to ask them, did you get an A? So remember, specifically in this chapter, everything is categorical. Like, are you in the age group 18 to 19? Are you a Democrat? Those are all categorical questions. Although there are numbers here, that represents 131 people who said, I am a Democrat and I am 18 to 19 or 18 to 29. Both are categorical questions. This is bivariate categorical, which is what we just play contingency tables and mosaic plots with. Oh, you're fine. Don't worry. I didn't even see it, Catherine. But remember, chapter 22 is the only one for the nulls and the alternatives that we will use this format of X is independent of Y, X is not independent of Y. And truthfully, it does not matter if you flip-flop the X's and the Y's. This is the easiest question. Oh, it kills me when people get this wrong. They start writing mu and they start writing p, and I'm like, no! But it almost feels like p's because it's categorical, so I can see why people would do p's. It's really crazy if you do the p's. So there we go. We have the null and alternative. 1 part down. Probably 2 points on the test earned right there. Let's continue on. Condition 1, random. Condition 2, pause. Condition 3. Here's condition 3 for the moment. I want you to think about this. Usually when it's categorical, what do we have? I want you to think about this. Usually when it's categorical, we have the what condition? Success failure, which is kind of how many expected successes we have and expected failures given the null is true. Like NP naught and Q naught would be the number of successes based on P naught and the number of failures. So it's kind of like an expected, right? If the null is true. If the null is true, we'll have this many successes and this many failures. But watch it. You ready for the magic? Okay, wait, watch this. They'll see it online really well. You guys got to watch closely. How many, we have how many usually for the NP and Q condition? How many? 2, we want 10, right? We have 10. How many variables do we have this time? We don't have 1 variable, we have, what's 10 divided by 2? Whoa. There you go. With 2 quantitative variables, it's now expected cell counts are greater than 5. So we'll talk about what expected cell counts mean in just a moment. We're gonna do a lot of mathematical rigor today. This is a very kind of do you know the math chapter. The only way you get this chapter down is just by doing math problems. Just do math problems. You have to practice this one up. If you do this quiz, you do this homework, you do the CLQ, you'll probably be fine on this chapter. It's pretty straightforward. So one of my favorite chapters, pretty easy one to do well on the test. Just make sure you know this is the one where you don't use the statistical notation for the null. Very good important note there. So, do what? Always, we want the expected to be at least 5, and if it's 5, that's fine. So, oh no. So it's not that there's 2 levels to the categorical. It's that there are 2 categorical variables. Like you can see with the Titanic data right here, we have 2 questions we ask them. Like with the age group, political party, there's 2 questions. So it's not really based on the number of categories inside of it. It's based on the variables, the 2 variables. Good question. 5 points, Stuart. I like it. It's always 5. So I call that condition 3 because it's like the success failure. Now we have a 4th condition. How do you know when there is a 4th condition? Why is there a 4th condition, Brian? I don't know. The only other time we saw a 4th condition was when we had 2 means. In chapter 20 with 2 means, the means need to be independent of each other. In chapter 22, when we have 2 categorical variables, it will follow. It has to be that we will have count data. And I call that condition 4. I go through in order again. Condition 1, condition 2, and then condition 3 is similar to the 10 successes, 10 failures, but this time it's 5 expected cell counts. And then condition 4 is that the data is count data. That is met because both variables are categorical. This is very similar to QQ. QQ, straight enough, no outliers. What did QQ mean? Both variables are quantitative. Categorical just means both variables are categorical. 2 categorical variables. And, that's all you had to say for QQ was both variables are quantitative. All you have to say here is survival on the Titanic and class on the Titanic are categorical. Frankly, we'd probably accept both variables are categorical. You can just memorize that and probably get the question right as long as you know if you see a mosaic plot, you meet this condition. That's it. Random, the Titanic data probably doesn't meet the random condition because these people weren't randomly assigned to classes. But I guess you could say the people in each class were random. It's a little iffy. There's issues if you start talking about that one too much in depth. The 10%, less than all 10% of people who rode on like cruises, maybe. Titanic one's not the easiest one to use all these conditions on. It might have problems because it's a very hard, thing to extrapolate to what would happen on all cruises. And also the Titanic is a product of its time. I feel like nowadays if someone's yelling, women and children first, someone would be like, to hell with that. And they'd be like Snapchat and they'd be like, I'm getting on this boat. I'm just like, me, Brian Stevens on this boat right now. My boat. just leaving. That would be a horrible Snapchat story. That'd be bad. So for the 4th condition, we can say this condition has been met because both variables. Yep, that's all you need to say, Sequoia. Excellent job. Don't ride on a cruise with Brian Stevens. He'll save himself first. That's horrible. You don't know what you're going to do in situations like that, do you? Everyone's like, I'd save everybody. I'd give them the last ship. But you ever watch the movie Titanic? There's like a dude who takes a boat by himself. There is. If you watch that movie, the movie is a documentary of what happened. There was I don't know, probably wasn't. Okay. What is meant by these? So let's actually talk about this expected, because you're like, Brian, what does this expected even mean? I told you the condition. That should be enough, right? But we want to go further. We want to understand. We just talked about behavior, ethics, and philosophy. It's really interesting how people say they would react versus how they react. Very, very true. Because if I say, oh, of course I'd let people on the boat, would I? Only know when it happens. So let's talk about the expected condition. Nice comment, Square. I like it. What we have here with the expected condition is actually a bunch of math that we've been doing. Think about this. We assume that they're independent. So if we assume that they're independent, we're going to do a formula of row total times column total over grand total. All you really need to know is down here is row total times column total over grand total. And let me see if there's a good way. Let's go over to Google right here. Let's get a contingency table. And good. Okay. We've got a cold length and medicine taken. Ooh. So look at this. You can automatically tell that these people who took medicine, right here. But if there was no association, There's 200 people here, and you basically have 100 here and 100 here and 100 here and 100 here. Do you see that? Very similar. Give a guess at what many of these cells in the middle would equal if there was no association between taking medicine and your cold being shorter length. Probably most of these would equal something close to what? 50. Now think about this. Which number do you think would be the smallest? The what days and the what medicine taken. What number would be the smallest if we did expecteds? And I'll show the expecteds in a half second, but I want us to think about this. Which row is the smallest? Which row has the smallest count? Four to 7 days is the smallest row. What's the smallest column? So look, there's 98 here, right? Does that make sense? There's 95 here. This one should be the smallest. See how odd that is, that that's not the smallest? See, I can calculate it. Let me show you the math. Here's the math. Not a hard formula. We take row total, which row total is 95. Does everyone see why I'm getting the row total right here? Does that make sense? Times column total. What's the column total for that 79 right here? Column total is what? 98. Row total times column total over grand total. And is that close to 50? You know what I can also do? I can tell you also all the other expecteds. Because if this is 46.5, this one has to add up to 98, like what is ever here. Interesting things we'll learn today. So I have no idea what's going on. Let's look at a better example right here, one that's going to make it really obvious which one will be the smallest. Really good kind of craziness right here. Which of these would have the smallest expected? Really good kind of quick question on a test right here. Which of these would have the smallest expected? Think about the formula. What number are we always going to divide by when we do a row total times column total over grand total? We'll always divide by the, just said it, we'll always divide by the grand total. So this number is the same for every equation, row total times column total over grand total. And how do you make a number bigger? You make the two numbers you multiply together bigger. How do you make the number on top smaller? Italy, Catherine got some points there. Italy what? Italy's the smallest column. And Hake, right here, this one right here, do you see 23? If I want to find out the expected, this is what we call the observed. In this frequency table, we have what we observed. Does that make sense? To find out what we expect, we take row total. Do you see how I have row total, everyone? Times column total, which is what? And then divide by grand total. And I want this to be greater than or equal to what? At least, to meet the condition, 5. And if I check the smallest, have I done all the work? Because if the smallest is greater than or equal to 5, then they all have to be. So I'm just checking the smallest to see if it works. And you can test yourself on a lot of this to test condition number 5. Uh-oh. Okay, let's test it out. This does not look good. Condition 3. Thank you, Gabby, 5 points. Hey, 5 everywhere. What's the smallest cell here? Oh, fun talks. This was just what came up. AIDS in both. So this one right here is just random thing come up on line. 9 times 5 divided by 30. Does that meet our condition? Nope. Doesn't meet the condition. We cannot do the chi-square test of independence. What is the smallest here? It's gray male, right? Yeah. So don't be tricked. There's ways we can trick you because you don't want to look for, you're not looking for, just everyone understand, we're looking for the smallest column, which is gray. Do you see why that's the smallest column? And then we're looking for the smallest row, which is right here. These are how you get, and what do? Row total times column total over grand total. I'm going to put it right here. The row total is 82. Doesn't matter which way you multiply. Column total divided by 167. Do we meet the condition? Yep. And you know what? You see how that's 9.8? 9.82. If I do this one right here, guess what it's going to be? 10.18. 10.17 because it's going to round. 10.179. Watch this. 20 times 85 divided by 167. 10.179. I knew that before I did it. Because what did I say about these expecteds? This is a cheat right here. The expecteds have to add up to what? Because what does 9.8 and 10.2 equal? 20. Does that make sense? The expecteds, because they have to add up to the totals, because the expected are just ratios by the given rows and columns. So that's all it's going to be. That's a quick trick right there. You can find out an expected just by knowing one of them. I think this one was 1.5 right here, right? This one was 1.5, right? So this one has to be 3.5. So this one right here will be 3.5. 5 times 21 divided by 30, 3.5. Because 1.5 and 3.5 equals 5. So that's got it. Quick trick right there. So this whole slide right here, all that math you saw me do many times, review that if you want in the video, but that's how you find an expected, is row total times column total over grand total, get you that specific expected. How many expecteds are there in this table right here? Hard. Let's go for an easier one. How many expecteds are there right here? Careful. How many expecteds are there? Correct answer, Montana, 5 points. Montana said 4. Because 1, 2, 3, 4. You don't use the totals for the expecteds. They're just calculated things for you. How many expecteds right here? 12. Nice job. Stuart, I don't know if you give me 5 points. I like it. So there's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Does that make sense? Each one of these would have an expected, and each one of these has an observed. We observed, oh man, this is a cool one right here. We bowling? What? I want to do this data now. I want to find out what's going on. So it's like, what snacks do people eat while playing a certain game? Do people eat different snacks? Like, the snacks people eat are independent of the game they're playing. The snacks people eat are independent of the game they're playing. There you go. Play some Wii bowling. So, people play pizza rolls and ate Wii bowling. We observed 12 people doing that. But we expected, and I'm just finding this one at random, 43 times 23 over 115. How hard is it to find an expected? Do you understand how to find an expected? One thing I often do is I can write out the equation. Sorry, onliners. That's why I did a whole bunch of work for doing this. That's the equation for this cell right here. That cell right there is the equation right there. Do you see how I've written the equation? All I did was circle this number right here, circle that, circle this number, times this right here, and then over this. Does that make sense how I wrote that equation? Row total times column total over grand total. Because this is the row total times the column total over the grand total right here. And that's for this cell. Because this and this line up across here, line up across here. That lines up right here. So that's where this and this line up. Very important you can do that. So we're doing the mechanics hardcore today. We got a lot of practice problems. How about this difference we see? Well, when you think about it, some are going to be high, some are going to be low. But remember, both of those were 10. And one was 10.2 and one was 9.8. If we add up all of these differences, what will the differences be? If we add up all these differences from the observed and the expected, they'll all add up to what? Don't know how you would know this. They'll all add up to what? They'll all add up to 0. Well, that doesn't tell us anything. How about we do what to those differences? Square them. Take the differences and square them. Now you have the squared differences. If you add up squared differences, all squared differences will be what? Anything squared has to be. Anything squared has to be positive. Nice job. 5 points, Gabby. Anything squared has to be positive. So now we're adding up a bunch of positive numbers. And think about this. The bigger the difference is, the bigger it gets. Because of a difference of 4 is 16, a difference of 10 is 100, a difference of 20 is 400. So the difference is just balloon in magnitude. 10 is 100, 20 is 400, 30 is 900. Can't do math today. So you see that difference of 10 goes from boom, 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 just goes way out through the roof. So these squared differences will push towards outliers. But we need to kind of do it by relative size. So I want to do this example real quick. Who wants a job in class? Okay, Gabby and who else? Right there in the back. Okay, you ready? So if, Gabby, I say to you, Gabby, I'm going to pay you, let's say, $10 an hour. And then I end up paying you, let's just wait for it, $110 an hour for a job. How do you feel? Gabby feels great. So I told Gabby, what did you expect to get? I said I'd pay you $10. What did you expect? 10. What did you observe getting paid? 110. We'll do this equation in a second here. Now in the back, oh, Brian's so generous, right? So here we go. You ready? Okay, I have a job for you. It's a year-long job. I'm gonna pay you $30,000. But you know Brian changes his word at the end. So you're like, this is gonna be really cool. I mean, he times her pay by 11. You ready for this? So what do you expect to get paid? $30,000. So I told you I'd pay you $30,000. You expect that, but wait for it. When you get paid, I pay you $30,100. Gabby was so excited. Are you excited by that change? A little bit. Well, she's ecstatic. She's jumping for joy. But you both saw a difference of what? Do we agree that the observed minus expected for you both? You observed for $30,100, you expected $30,000. You observed $110, you expected 10. Both of you up top, solving this top part of the equation, would have what squared? Careful. 100, because 110 minus 10, yeah. I had to think in my head too. Or 30,000, you observed 30,100, you expected 30,000, difference of 100 squared, so there we go. But when we standardize by yours, 100 squared is 10,000. You can already see where this is going. 100 squared is 10,000, divide that by 30,000, and your chi-squared, we'll talk about that in a moment, is 0.33. But how much more excited was Gabby? 10,000 divided by 10 is 1,000. She is 3,000 times more excited than you. Like if we quantify it, does that make sense? Like when we standardize this metric right here, like z-score it, we're kind of z-scoring this right now because it's observed minus expected squared over expected, often like an observation minus mean over standard deviation. That's what we're doing here a little bit. We're making a standardized result. So she's way more excited, 3,000 times more excited than you. And I'd say that seems relatively real. If I found out my job was going to pay me $10, I'd be like, oh yeah, that's all right. And then they pay me $110, I'd be like, dude, I only got to work like 10 hours a week. I mean, 10 hours a week, you'd make $1,100 a week. I mean, you could live all that. That's not bad. 10 hours a week, 1 day a week work, just one hard day of a week. You get the rest of the week off. You're done. Got your $1,000 for that week. Not too bad, right? Yeah, be great. $30,000. You had to work all year for that $30,000. You get $100. You're like, thanks. I mean, it's nice of you. Gabby's just relaxing every day. But, well, 1 day. You got to work 1 day a week. Man, if you want to work 5 days a week, you have $5,500. Be nice. So, yes. So it's $250,000 a year, I think. So what are we going to do? We're going to take all of these observed minus expected squareds. And what you can think of for each of these observed minus expected squareds, this is how odd each of the cells is. So each of these observed minus expected squares is a cell chi-squared. Tell me. Go back to here again. Let's do the easy one. How many observed do we have in here? I want you guys to tell me. I want you to know the notation. How many observed are there in that table? How many observed counts do we have? How many observed counts do we have? How many observed counts do we have? 4. Nice answers online. So 4, Catherine, 5 points. I don't know if I've given you any lately. So we have 4 observed. This is observed. This is observed. 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 How many expecteds do we have? That's an easy answer in class. How many expecteds? 4. So each observed has its own expected. Then we'll look at the difference from that, and then we'll standardize by its expected. And thus, we will get a cell chi-squared for each. How many cell chi-squareds do we have? 4. And then what do we do to all the cell chi-squareds? As you might have saw on the next slide, we simply take all the cell chi-squareds and do what? What's this thingy? Sum them all up. We just sum them all up. We add all the cell chi-squareds for the chi-squared test statistic. The chi-squared test statistic is the sum of all the individual cell chi-squareds. So it's like the cells make up the test statistic. It's the individual components of the chi-squared test statistic, the cell chi-squareds. So you must start from the beginning. Observed. You must then use your row and column totals and grand totals to get the expecteds. You must then do observed minus expected squared over expected to get the cells. And then with the cells, you add them up to get the cell chi-squared. You add up the cell chi-squareds to get the cell, oh my gosh. You add up the cell chi-squareds to get the chi-squared test statistic. More specifically, the Pearson chi-squared test statistic. I couldn't speak there for a moment. I just kept saying cell at the end. The cell chi-squareds add up to the Pearson chi-squared test statistic. It is like the T. The chi-squared test statistic is like the T in that it has degrees of freedom. Now, what's the cool thing that you don't super need to know, and everyone turns off the brain when I say that, but I think it's so cool, is that the chi-squared is like, it's like the T, that the more degrees of freedom it has, the more normal it gets. Do you see it becoming more normal? There it goes. Do you see it turn into the normal? It's a bit weirder. Don't worry. All we're going to do is, guess what? We're going to take our chi-squared cell statistic, plot it, and get a p-value. Does that make sense? This is a one-tailed test, but test to see if there's a difference. Technically, we are doing to see if they're not independent. This test would conclude here that x and y, we would say we what the null. Do we reject or fail to reject the null? Here. Fail to reject the null, so what? We would believe that they're independent or not independent. We would continue to believe they are independent, yes, because we have no evidence that they are not independent of each other. So we would continue to believe that they are independent if we got this. This is the sum of our cell chi-squareds. This is one with 4, and I can show you one with 4. Let's look at this cool formula right here. It's nice and easy to see. So I think I saw one that had 4. Thought I did. Oh no, I think we have one in the examples. Nope, that's 3. Here's how you play the game. Row totals, watch this. Take one row, mark it out. Take one column, mark it out. How many cells are left that you're actually using? Not the totals. 3. Rows minus 1 times columns minus 1. This is a 2 by 4. 2 rows, 4 columns. A 2 by 4 turns into a what by what? A 2 by 4, when you delete one row and column, is a 1 by 3. And how many cells are in a 1 by 3? There's 3 cells. And think about this. If I know all the answers to all those first alive, second alive, third alive, if I know all of those answers, could I figure out all the rest of the answers? Because think, if I know first alive, then whatever first dead is has to add up to the total. Does that make sense? Then if I know second alive, second dead has to add up to the total. If I know third alive, third dead has to add up to the total. Now I know everything in the dead and the alive except for the crew, which the crews have to add up to the totals. So that's why we call them degrees of freedom, because everything else is contingent on them. And all you have to do is just mark out one row and one column. In some of our easier examples, we can look at some stuff like this. How many degrees of freedom does this have? Be careful. Just say to me, Brian, that is a blank by blank. It turns into a blank by blank, thus has this many degrees of freedom. Does anyone want to say that in class? 5 points. Say it to me. Brian, that is a blank by blank. It turns into a blank by blank and has blank degrees of freedom. Yeah, Stuart, no. Fill in the blank, Stuart. 2 points, Stuart. Hint, hint, 2 points. It's a 2 by 2, turns into a 1 by 1, and thus has 1 degree of freedom. That means we are using the chi-squared with 1 degree of freedom. Brian, be careful. This is the mistake people make. Nice, 5 points, Catherine. So, and it has 1 degree of freedom. Perfect, Catherine, nice job. This one, people get confused because they start using the totals. The totals are not a category. You're doing how many categories they are. Brian, that is a blank by blank. It turns into a blank by blank, thus having blank degrees of freedom. Give it a shot. Go ahead. Yeah. So just to reduce each one by 1. That's fine. 4 by 3, 3 by 2. Doesn't matter which way you multiply, doesn't matter. But I'm just keeping it the same. 4 by 3, 3 by 2. So 3 by 2 is, just multiply them. You're right, that's it. 6 degrees of freedom. Can you see the 6 degrees of freedom? I don't know if I can draw on this one, but it'd be from here to here. Does that make sense? It doesn't matter which way you mark out cells, but it's just the inner cells with one row and one column removed, the inner part. Be careful. Some people mark out the totals and they tell me it has 12. I see that a lot on the test. It's not the total columns. This one looks really confusing, but Brian, that is a 1, 2, 3, 4, 5, 6, 7, 8 by 4. That's an 8 by 4. It turns into 7 by 3. It has 21 degrees of freedom. That means to me that I'm using a chi-squared with 21 degrees of freedom. This is the chi-squared distribution I'll be using. That's what it tells me, the associated chi-squared distribution. Does everyone understand how I'm getting the degrees of freedom? I love this chapter. Brian, this is a 5 by 4. 1, 2, 3, 4, 5. It has no total columns. Watch out. Sometimes we don't have those. It's a 5 by 4 that turns into a 4 by 3. This has 12 degrees of freedom. There's your 4. There's your 12 degrees of freedom right there. Brian, this is the one I was... Nope, he's not the one I was thinking of. Brian, this is a what by what? A what? Careful, careful. You did it. You did it. You did it. 2 by 5. Careful. That's why I keep doing it. So someone said the totals, which is all right. I see that a ton on the test. That's a mistake people make. It's a 2 by 5. We're not counting this. The totals don't count. They're not a category. We just use the categories. It's a 2 by 5 that turns into a what by what. So it has practice. I love practice. Do you guys like practicing this? You like all the examples? Online says no. They hate examples. Online says yes. Try and do as many examples as we can today. All the practice. Go back and review this video. Lots of examples. It might even make a lot more sense the second time around, but I'm just hitting you hard with examples today. As many examples as I can think of. One last one. Why not? Brian, this is a messy one. These are the totals. These are totals. This is a 3 by 4 turns into a 2 by 3, so that's 6. Does that make sense? Good. That's a weird looking one. Usually you get nicer stuff. Brian, this is a 2 by 3, same total as all 4. And look, 2 by 3, how many degrees of freedom? 1 times 2, right? 2 degrees of freedom. There you go right there. And this does have problems. The minimum expected cell count is 1.5. It's alerting us to that problem, which we calculated for that one already. Good stuff. Lots of examples. Online likes examples. It's probably weird when you watch the videos and you can't see the chat. We got to right here. Recall our null and null alternative. So we're going to use and this is just the things I was showing you. So this is some theory on it. Let me go to that. What's going on here with the chi-squared test statistic is this. If the null is true, what is the most likely thing or things more than extreme to that? Think of this. If the null is true, then they're independent of each other, right? So the observed is probably what to the expected? Like if we expect something and we observe, they're probably what to each other? If the null is true and they're independent, then we probably observe what we expect. So they're going to probably be, we'll observe what we expect, so they're probably equal. So if we observe what we expect, they're probably equal. Did you say equal? Yeah. 5 points. Okay. So if we observe what we expect, Montana 5 points too. They're probably equal. So what is if they equal, what's observed minus expected? 0. And when we square that, we get. And then when we divide that, we get. And then when we add up all the zeros, we get. Do you see it? That was all the math right there, right? So what was the chi-squared test statistic if everything observed and expected are equal? What's your p-value? That's the most likely thing to see, or things more extreme than that. Hence, the most likely thing to see is there's no difference between the observed and the expected, because if the null is true, we should see things close to the observed being close to the expected. The greater the chi-squared, the greater the deviation, and the less likely. Does that make sense? Literally, the slide says it that we're on right now. It says, like, the larger the chi-squared, the smaller the p-value. And this works for all chi-squared distributions. They all start at, I just went off the scale there. They all start at 0, because the smallest deviation to have is 0. The chi-squared is a right skew distribution that starts with 0. So the smallest deviation to have, observed minus expected squared over expected, is 0. And the smallest sum of all the deviations is 0. Aslan, 5 points. I like all the zeros. So racking up the extra credit today. So that's what we're saying right here. When the chi-squared statistic is large and the deviations are large, we'll see a large chi-squared. It can't be too small or negative. Chi-squared can't be negative. So yes, small chi-squareds are not a problem. Small chi-squareds are what we expect. So if you see a small chi-squared, it's probably what we expect. So what kind of car should you buy? So maybe the maintenance, if your car needs regular maintenance or regular and unexpected maintenance, above and beyond maintenance, maybe that is dependent, we'll say it properly here in a second, on type of car. Remember, all you need to say is maintenance experience is independent of the type of car. That's easy, right? And then how do you do the alternative? Maintenance experience is not independent of the type of car. Sometimes we say associated. I just like to say independent, not independent. So easy. Just say that. It's this, it's not this. I mean, that's the complement. It's either independent or not independent. It has to be one of those two. So here we are. What are we doing right here? We have the counts. This is all of the counts, I believe. Maybe I'm wrong. Let me double check. 42, 24, 34. That is the counts. But these are now the totals. So we have the totals down here, and check it out. We have the formulas showing you. How did we get 37.94? Do you see this is Ford regular maintenance? Tell me the formula. Do you remember the formula from earlier? $146. So,
Oh, yeah, that's how you.
times 52.
Shoot, I didn't know they were close.
Yeah, the row total times column total or grand total. Yeah. So just take the row total times column total or grand total. And you know what you notice also? What do you think 14.04 plus 37.96 is? Yeah, it's right there. I'm not looking. This is going to be 82, right? Yeah, it's 82. I didn't look up. I just was like, I don't want to say the wrong number. I was like, it's 82 or 72? Because it's weird when you see the two, you want to say 72, but you got to remember it's added up. So these two numbers right here add up to 82. These three numbers across the board right here add up to 146. These three numbers across the board on the bottom right here add to 54. They have to add up. All these numbers in here add up to 200. That's a quick check on the test. But how hard is it to be like, oh, I want to get the expected cell count for this cell right here. 54 times 82 divided by 200, 22.14. Row total times column total over grand total. That's all it is. That's the formula for expected. Now we go about and we get, that's just showing you the math again, is it? Row total times column total over grand total. Math. Now let's get the cell chi-squareds. We don't make you do this much work on the test, but this is showing you all the steps, every step. So when we look at this right here, you can take, like we just got the 22.14, just take it like this. Watch this. What's the difference between these two numbers? It's basically what? 10. What's 10 squared? 100. What's 100 divided? 10 squared is 100. And then when we divide 100 by 22.14, we get between 4 and 5. Because 100 divided by 25 would be 4, 100 divided by 20 would be 5, we get between 4 and 5. Think about this. This one, right, let's find a really nice one. This one's not as nice. What's 4 squared? 16. 16 divided by this is apparently this. Does that make sense? That's all it is. Because I like it. There's an example coming up later where the numbers are nicer. But does everyone understand? Like this one right here. What's the difference between these numbers? The difference between these, just look at the total difference between them and round it. 4, 16. What's 16 divided by 38? I'm just rounding the numbers, and we get, Ryan doesn't know how to buttons, and that's basically it with just rounding differences. Does that make sense? All you're doing is taking the difference between the two numbers, and this difference right here is 6. 36 divided by 48. That one makes sense, because divided by 12, it's 36 divided by 48 is 0.8 or 0.75. I just came to math today. So, yeah. And do it more exactly, and you'll get the more exact answers. I'm just kind of quick hand showing it right now. Like, I'm just being like, oh, we could do this nice and quickly. There'll be some more exact ones. Remember, it's observed minus expected squared over expected. Put in the exact numbers. We're just kind of seeing how it works because it's nicer. How do we get the chi-squared test statistic? We take all the cell chi-squareds and what? Add them up. That's all it is. The chi-squared test statistic is the sum of all the chi-squared, the cell chi-squared. The chi-squared test is the sum. So we get 10.82. How many degrees of freedom does this have? Brian, this is a blank by blank. It turns into a blank by blank, having blank degrees of freedom. Brian, this is a 2 by 3, turns into a 1 by 2, has 2 degrees of freedom. That's it. That's all it is. And see, there it is. I'm going to view it more visually. 2 degrees of freedom. There's the chi-squared, general skew, and our p-value is that. I think that's the same thing we have on the slide, or very close to. That the slide just rounds it, and this is the actual. I like this one. Nice job, Catherine. I like it. So it's 2 degrees of freedom. This is the proper chi-squared, and all we do then is graph it, and it graphs the area to the right. It's so far over you can't see it. Does this mean there's an association between the car you have? Like, do we have evidence that there is an association? And that's one way of saying it, but would we reject the null? Let me say it that way. Reject the null or fail to reject the null. So the car you get is not independent of the maintenance. Like we have evidence that the car you get is not independent of the maintenance, meaning that there is an association. It's the same thing of saying that they are associated. Let's look at the mosaic plot right here. After we reject the null, oh my gosh, what car are we gonna buy? All we know about cars is this: we're gonna go out and buy ourselves a... We don't know. Toyota, a brand new Toyota. So right here, is it pretty obvious that this is a lot more than you would expect? Because right here is the marginal display, and if there really is no association, they should be pretty close. Is that pretty close to the other ones? Is that a little deviation or one that's unlikely to happen by random chance? Hence, the p-value below 0.05. That deviation there is unlikely to happen by random chance. That's. I mean, yeah, they could be a little off, but this is a lot more off than we would expect due to random chance. That's a big deviation. We can look at the percentages. This has been the bane of some people's existence on the test. We ask people to calculate the percentages right here. Look at this. We are within Toyota. Does this make sense? Do you see how I'm within Toyota? Go within Toyota. Look at the total. How many total Toyota cars were there? 82. How many of those 82 needed regular and unexpected? 12. What do you think 12 divided by 82 is? 14.6. Because if you go within one of these, like right here, within Ford, do you agree right here that this is within Ford? And this also right here is within Ford. It just turns it. That's what blows people's minds on these tables. But let's go within Ford. There are how many total cars within Ford? How many total within Ford? Look at the total for within Ford. 52 total within Ford. That's right over here. There's total 52 within Ford. And there were 18. When I divide 18 by 52, I should get 34.6. That's where that number is being obtained. Those questions are a little bit difficult for people, but see if you can solve out for all of these numbers. Good kind of test right there for you. Let's see. It doesn't matter if you change the X and the Y. It's just a very, very quick note right here. Just depends on your audience. Does maintenance experience explain which car you have? Just depends on how you're looking at it. So it can look a little bit different. Nothing too much going on. This could easily be a true-false. Switching the X and the Y on a mosaic plot will change the results of the test. No, doesn't change it. So that's the only thing I could think of a true-false question to come up with this. Like, changing the X and the Y will change your chi-squared values. No, the math will still work out the same. The numbers are still going to line up. Like, this row total will still associate with this column total right here. You'll still get the same counts in the expected and the cell chi-squareds. The math doesn't change. So that's a quick thing right there. Does this mean that this is a common question too. The last thing right here. So when the p-value is below 0.05, we do reject the null, but that doesn't mean that one causes the other. This is not an experiment. Only experiments can show causality. When you hold one thing constant and try to shift another, that is how you look at causality in a controlled environment. So this does not show causation. It might just be that, maybe, I don't know. I can't think of anything for this example. Maybe people who buy Toyota trucks are nicer to their car. So it's not that the car itself needs less maintenance. Maybe people just keep better upkeep. It's just like Toyota owners are better owners of their car. Could that be the case? Maybe. Maybe it's not the car itself. So if we did an experiment, we would randomly assign the cars to people. That's how you would actually do it. But this was not an experiment. It was just an observational study of let's look at this. Let's do an observational study on prostate cancer. Woohoo! All the fun topics today in Stat 201. Congratulations, this is the last lecture. And the last example is prostate cancer in fish. Thanks. I didn't write this lecture. Okay, so this one right here, you could say maybe it does meet the randomization condition. Like sometimes I get too theoretical on these things, but we didn't randomly assign these people to like groups. But it is kind of random. They're like, I think it's all right to assume this is random. We just have random people from each group. So yeah, I think that's all right. We're randomly collecting people who, just are people from the population of interest. Does that make sense? We're going to randomly collect people. And I just got in the brain of experiments. Ignore last things I said because I was thinking experiments, which is a totally different thing. So I've been doing experiment stuff lately. But we randomly chose people from Sweden, where PewDiePie is from, Brofist. Yeah, I'm going to get another copyright strike. No! And this is count data, correct? Well, condition 1, random. Condition 2, less than 10% of all of Sweden. As long as Sweden has more than about 62,000 people, because that's times 10 of this, we're fine. I assume it has more than that. The expected cell counts. How am I going to check the expected cell count? Which numbers do I multiply together? We did this a lot earlier. 466 times, which one? That's the smallest row total, smallest column total. Is that greater than 5? We meet the expected cell counts greater than or equal to 5. Multiply the smallest row total times the smallest column total, because you could check all of them, but just check the smallest. And last but not least, is it count data? Yes, we asked someone what amount of fish did they eat, and it wasn't quantitative. We said, did you eat a lot, a medium part? Was it a large part of your diet? And did you get prostate cancer? Apparently they don't mind us asking this in Sweden. Thank you, Swedes. You're so nice. Look at all this great stuff right here. This is stuff we do on your test all the time. So when you get this on the test right here, you see that this expected cell count is missing. Guess what? There's a lot of ways to solve it. Because I could take 2978 and subtract out 2756.74. That expected cell count is 221.26. And watch. What's the row total for it? Do you see it? What's the column total for it? Is that what I got? I think it is, right? I hope. 221.26. We can double check. 221.26. $221.26. Yep, same thing. Found it 2 ways. You can double check your work. When we do this expected right here, I'm going to do it in my head, not the expected. I'm going to do this cell chi-squared. Also, I think it's pretty obvious the counts add up to that too, right? Is that pretty obvious? 110 plus 14 equals 124. Counts add up to their totals. I didn't say that in class, but someone will be like, Brian, you never told us the counts add up to the totals. Like, well, that's why it's called a total. It just happens the expecteds add up to it too. What is the difference here? It's close to 5, but it's in between 4 and 5. So between 4 and 5 squared is about 22. 22 divided by 114. This is going to be about 0.47. That's my best estimate. So the difference between those two is this. I said about 0.47. And then we're going to square that. Difference squared. I said 22. I was kind of close on that. I said 0.47. My brain is off today. That's why we do the calculator. But that's what the cell chi-squared should be. Observed minus expected is merely the difference between these two numbers. Does that make sense? And it's the positive difference, so I don't even care if it's negative, because I'm just going to make it positive anyways. So when you do some easy ones right here, I thought we had an easy 1 or 2 on here. And you can tell this one's basically 0 because it's basically 1, right? Basically, you have 1 squared, which is kind of 1, over a very large expected. That's why this is so tiny. This one's also pretty tiny too, because the difference is basically 1 again over 40-ish. I mean, it's bigger, but it's still nothing. Is there any easy ones? I thought there was easy ones later on. This difference here is almost 5. 5 squared is 25, but it's a little less. So it's about 23. 23 over 9 is, yeah, about 2.5. So just estimating in my head, 23 divided by 9 is about that. But if you do it exactly, you go 14, observed minus expected. Now I'm doing it exactly. Observed minus expected squared divided by, it's about as long to do it this way anyways. Observed minus expected squared over expected. Make sense? We're almost done. Take all your cell chi-squareds and do what to them? Add them all up. That will give us the what? The chi-square test statistic known as the Pearson. This is a way to remember which one is the one. The Pearson has your p-value. The Pearson has your p-value. If I edited this video, it would be flashing on the screen now, like mass blinking, like red alert. The Pearson has your p-value. So when people say to me, Brian, which one has the p-value? The Pearson has the p-value. Your site that you do your homework on is what? Pearson. It has the p-value. Do not forget. Well, let's go back and find the degrees of freedom. Brian, this is a what by what? 4 by 2 turns into a 3 by 1 has how many? 3 degrees of freedom. So we can confirm this answer. The Pearson is 3.677. P-value is 0.29852, and that's what it would be right here, 0.29852. Usually they're kind of close to each other. There's small differences in the way they're calculated, no worries. R squared, very low, so probably not significant. In conclusion, we do not reject the null. P-value was way above 0.05. It was like 0.30, rounded-ish. And so what I would say, if I was to talk about this, with a p-value of 0.92, with a p-value of 2.9852, I do not reject the null. The observed discrepancies, or the differences between the observed and the expecteds, that we saw in this contingency table are likely to happen by random chance. Does that make sense? That these two variables, I would still believe are independent of each other. I still believe the amount of fish people consume and whether or not they get prostate cancer are independent. And that is shown because right here, you do not see a really big increase. Like look at this yes bar across here. That yes bar is pretty flat. I mean, it does change some, but those differences, hence the p-value, are probably due to random chance because the p-value is the probability of our results or results from our stream happening due to random chance, given that the null is true. So if there is no association, these differences they're likely to happen by random chance. Does this study prove? Prove is a very bad word. It failed to show evidence. Never prove with what we've done in class this far. This study failed to show evidence that there's any link between eating fish and prostate cancer. So go have some fish tonight, or I'm gonna have steak and duck and good stuff. I'm not gonna have duck. Girlfriend will have duck. That's it. We'll meet on Thursday. We'll review. Maybe I'll take some suggestions. Please fill out the SAS reviews. I'll love you forever. Duck, duck. Garrett, good to see you, Garrett. Do this assignment. Garrett, 5 points for saying duck. Make sure to email me the points for extra credit. Love it. That'd be a Michelle, 5 points. Michelle said that'd be a mistake to have duck. Mistake. That'd be a mistake. Duck. Yeah, like it. That's got it. Lots of examples today. You're welcome, guys. I feel like anyone watching this now, I want to stop the recording. Can I pause the recording? I don't know. I feel like I feel like this was one of our best utilized classes. Like we did lots of examples. We ended pretty much exactly on time. I didn't feel rushed at all. It's just hard to be like, it only took all semester for me to learn how to teach. But you know, we ended 2 minutes early. We did have a little bit of like, talked about SAIS, but I generally know how long the lectures take, so I know where I need to fill, but it's always hard to end like right on time. Like it's like, yeah, we did. And we did lots of examples. But I feel like I feel like you guys are understanding it pretty well.
This one isn't
It's not so crazy, is it?
Yeah.
Yes, it's very just step by step by step.
Yeah.
And you'll see that when you do the homeworks. It's just literally, you're already on the last round. Yeah, it's not bad, is it? Yeah. Yeah, it's a very useful one. This is highly used in research or in biology, and this is Mendel's p-plants.
Oh yeah,
So,
I know. I can do that.
yeah.
Like, it's all about
Yeah.
Doesn't make any sense now. Like,
Yeah, it's just you're measuring the deviation from the observed and the expected. You're standardizing, but then you're adding up all the deviations.
what is the degree of freedom I have?
It's just based on how many cells there are. All they needed was like 50 minutes, and they could have taught you. It'll take 50 minutes to call in Brian Stevens. Well, good night, onliners. They're not in here anymore, but I'll say good night. Good night, Stuart.